Okay, let's go ahead and get started. So today we're going to finish up on doubly linked lists. Before I go into that, I am not going to be here tomorrow. So if you need any questions about, I don't know, your labs or project, I will not be here tomorrow to answer them. But I will be here on Wednesday, which is when your project's due. So you can come
12 o'clock at midnight?
Yeah, right before midnight. So you can come and ask questions then. Please ask more today. I will try and answer email tomorrow, but no guarantees about answering email. All right, but we're going to go ahead and go into doubly linked list. So what do we recall from singly linked list? Let's go ahead and do a quick review. What was nice?
Head.
Huh?
Start at the head.
Start at the head.
And that points to first node.
Mm-hmm.
And then that node has a little box thing that points to then the next box.
That one points to the next point. Yeah. So what was a nice advantage of a linked list over, well, what's our other data structure? Arrays. So what are some advantages of a linked list over an array?
You can insert anything at any position.
Quickly.
Easily.
Yeah, easily. You don't have to shift the whole array down. You just move some pointers around and now you're done. What is the primary disadvantage, though, compared to an array?
Iterating through. Iterating through.
You can iterate.
But it's slow.
I wouldn't say it's necessarily that much slower iterating through, but you're on the right track. It's not iteration as much as something else. What was nice? If you wanted to get the fifth element of the array, what do you do?
Just go to index 4.
Just go to index 4. While in a linked list, you have to.
Row to 4.
Good morning. All right. So which one is faster? The array, right? So for random access, if you know the exact position you want to be in, the array is faster. But in the linked list, you can add to it a whole lot faster than you can with an array. Okay. So beforehand, we talked about a singly linked list, which looks something like this, where you had one pointer always pointing to next. Now we're going to talk about a doubly linked list, which hopefully you can tell has a pointer going to the previous. Why would we want to do this?
In case you want to go back.
Okay.
I guess.
Golf club. All right. Good job. We got that. What would be the advantage of being able to go both backwards and forwards?
Why?
Why not?
I honestly have no.
You have no idea. All right, what's the second bullet right there? Or the first?
Can we traverse in another direction?
Oh, so if you wanted to
Yeah, go backwards, like I said.
like reverse something, well, if you want to reverse something, that'd be advantage. But there's a bigger advantage in that one. Hopefully this will become obvious in a minute. All right, all the operations on doubly linked lists are the same. All right, that's fine. Default constructor, still want to be able to destroy and initialize. The idea here is that you're still going to want to create a node. Every time you insert a node, you want to make sure you insert it at the correct location, and you want to make sure all your links are correct as well. Make sure you can get a length. Okay, wow. Searching the list, still the same thing. You still have a front and a back, or what we call a head and a tail. All right, now we want to insert. Well, here we go. Insert is going to be a little more complicated because now you have 2 pointers to update. And in this example, by the way, we're not going to do the code for a doubly linked list. That's your lab. We're going to talk about it, and I'm going to let you loose in order to do it. That's why we're not coding right now. Not a problem, anytime. So you want to insert 20. You find out where that needs to be, namely before the 24, but after the 15. And what difficulty has been added here?
Another point.
Yeah, some more pointers. What do you think is actually easier now than with a singly linked list?
Insert.
Okay, well, why is that easier? Let's see, do they throw the code up? No, okay. If you recall previously, if we wanted to do this in a single linked list, you'd have to have a pointer to 15 and then 24 because you need to know where, you need to be able to update both pointers.
So you don't need to go straight to 24, you can just go straight to 20 and then 22, 24 without.
So right now, if you're at 24 and you want to insert something beforehand, you can because you have a pointer going to 15, so you can grab that pointer up and then update all the links as well. Because beforehand, you'd really need to get a pointer to what came beforehand, only before, and then because you need to update your next pointer as well as where it's going to afterwards. If you had in a single linked list only a pointer to the 24, you couldn't update your previous node because you had no way to jump back there. But now in the doubly linked list, you have a way to jump back there. So now in the doubly linked list, you can, with just one pointer, you can do it. You can add something before a node or after a node with no problems.
So in the single linked list, we had to have a pointer to the first, the element
To the
before.
previous, yeah.
Now we need to have a pointer to both.
No. Beforehand, in a single linked list, you had to have it before. You cannot do it with the pointer that came after. In a doubly linked list, you can do either way. The reason in a single linked list you had to have it before is because you needed that pointer, namely from that 15 going to the 24, so you can update 20 to point to 24, and then 15 to go to 20. If you did not have that, and you only had 24, you could have 20 go point to 24, but you had no way to reach back to 15 to tell it to go to 20. That was the problem with the single linked list. While the doubly linked list, that issue does not exist. Are you still confused?
No, I'm good.
Okay. Before we go on, let's talk about this. What order should you update all these pointers? Because this will be very important when you program this. Say you have a pointer to the 24. All right, you know that the 20 needs to come before the 24. What pointers do you add first? Which pointers do you set first? Actually, here's the first question. How many pointers are you setting?
4.
4, right. So there's 4 pointers you need to set. 2 of them are a modification, namely from the 15 next and the 24 going previous, but the other 2 are from 20 hooking those up. So which 2 do you think need to happen first?
The ones going back.
Okay, so we going back, which one would you set first? You said, I would actually highly recommend you set 20's pointers first, because that way, I mean, those are good news, right? You're not changing anything. So if you set 20 first, so you set it previous to be 15 and it's next to be 24, you still have 15 pointing to 24. What can you do next?
Is that 15 point to 20? Or?
And yeah, so you can do that now because you have 20 pointing to the previous. So you can do 20 previous, next goes to 20.
Then just go to.
And then the other way, and then you have 24, so you can just have his, well, you can have 20's, 24's previous, sorry, going to 20, and then you're hooked up. The main thing to keep straight is I highly recommend you set up what the pointers that you're inserting first. That way you will always have access to the other pointers you need to set up. Does that make some sense? What's going on?
So did we like leave a daily pointer from 15 to 24? Or?
No, because once you set up 20's pointers, namely 20 points to previous to 15 and 20's next goes to 24, which you can do, then you can say, well, 20's previous, aka 15's next, should go to 20, and you can set that because you have a pointer to 20. And then you can say that 24's previous just goes to 20, and then you've hooked up all your pointers. Just do what you're inserting first, your new node's pointers first, before you actually manipulate the list, and that'll keep you out of trouble. All right. Any questions on insert? No questions? All right. How about delete? I'll ask the same question. I'll ask the same set of questions. What advantage do we have in delete on a doubly linked list over a singly linked list?
Just point to the. You can just skip.
You can just
skip the one you want to delete.
In a singly linked list, you still had to have the one before it. In the doubly linked list, you can have the one before it, or you can use the one after it, depending on which way you prefer to do it. It's up to you. Yeah, you just set the pointers to go around it, and then what do you need to do? Delete. All right. Keep in mind, and you'll probably want to, or that didn't help any, you'll probably want to look at either these slides, which are on GitHub, or in your book, which actually has some pseudocode for you, by the way.
What chapter are we on?
Which chapter are we on? Third? I don't know. It's the Doubly link. It's a link list chapter. Whatever that one is. Whatever. Look, I'm teaching topics, not numbers, okay? You want to take care of these cases. I do recommend you take care of the cases in the order that the book recommends. First, is the list empty? Because if it is, are you going to delete anything? No. The item to be deleted is the first in the list, so you must update the first pointer. Update the first pointer is what you need to do. Note, you may also have to update the tail pointer if the whole list only contains one object or one node. 3 is if it must be deleted somewhere in the middle of the list, and then 4 is if not deleted list, item to be deleted but it's not in the list, aka something failed. Make sure that you decrement your size or your count variable, and you should be good to go. All right, any problems, comments, screams? So this is always a fun one. We're going to talk about it. Keep this in the back of your mind. It may become useful one day. Right now, not so much. Circular linked list. Linked list where the last node points to the first. See how it can make a circle?
Yeah. It's like a for loop, but it just doesn't stop.
It just never
It
stops.
just keeps going.
Yeah, so iterating through this might actually be somewhat difficult since you need to keep track of when you came back to the beginning.
So pretty much what everyone told us not to do when we did C the first time, and now it's like, okay, you have to do it, you have to keep track of it.
Oh, they told you never to do the circle, or?
They told you never have it going continuously unless you have a certain number.
Right, you still have to, right, you need to have some type of sentinel to tell you when you're done. AKA when you've gone back to the first node. You can still be done, but, yeah, still be done, but it becomes a little harder. Why would we want to have this? This is a tough question.
Maybe you missed something the first time. Or maybe, okay, maybe you could be like looking for different sets of values, right?
Okay.
Like, say like the first time you're looking for ints, there's no int, so you go back to kind of doubles. Not like that. But
Oh, I see what you're saying.
something like that, like maybe
First, okay, yeah. so
names, let's say names, like you're looking for John.
All right. But I see where you're going with that. But you could also actually search for all that, which we can. Not bad. Good morning. Morning. One thing to keep in mind is that while the list is keeping track of something, you may have pointers from outside your list pointing in. So you may have something pointing into this node over here, which is not the first element, but you still want to be able to iterate through the entire element. You don't know where the list is, you just have a pointer here. And by having a circular one, you can at least go through and iterate through the entire list just by pointing in one item. And that's all I have to say about circular. I don't want to talk about it anymore. So there we go. Summary. Some big takeaways to keep in mind, because you're going to see this a lot, is now we have this idea of a node inside of the data structure. And already there weren't any nodes, you just held all the data types. Now we are actually encapsulating or encompassing our data type that we're storing inside of a node. And right now we just have our nodes pointing to the next and to previous. Keep in mind that these nodes are going to be extended to do other things depending on your data structure. Right, Jonah?
Yes.
Thank you, Jonah. Pointer to a linked list is usually called the header, the first. It's a dynamic data structure. It's going to shrink and enlarge as opposed to an array, which is pretty much static unless you make a new array. And yeah, the list is number of nodes. Wow, I guess we're going to have the summary of summaries. Or the extended summary. The nice thing about a linked list, when you insert or delete, you don't have to move any data around, and that's an advantage over arrays. You don't have to shift everything, only pointers, so that makes insert and delete faster because it's O of one instead of O of n. Singly linked list can only be traversed in one direction. Doubly can be done in both. Also, the other advantage is that once you have a pointer to either the previous or the next of what you want to delete or insert, you only need that pointer, as opposed to a singly linked list where you always need the previous. And yeah. Oh my God. Doubly linked list, previous and next, right? Traversed in either direction. Good. Any questions on linked list? No questions. All right. Everything's perfect. That's what I like to hear. Chapter 16, by the way. So remember, your lab is to essentially implement your doubly linked list. You might be helpful to copy some of the linked list code over and start updating it and try and putting it together. That might be a good way to do it. It's up to you, but it must be doubly linked list. Notice that the auto grader is going to give you a grade. The auto grader's grade for this one is not necessarily the final grade. I have to go in and inspect your code because the auto grader just tests for accuracy, not that you actually implemented with the doubly linked list. So keep that in mind when you get your grade back from the auto grader. If you only submitted a singly linked list code for the doubly linked list, I'm going to go back and remove points based on that implementation. Well, here's some questions. Some questions to answer, and you can put this either in your code or in a text file. What's the performance difference in appending between array, singly linked list, and doubly linked list? I'm looking for big O here. Now for performance of insert, and then the operator subscript, that'll be a good one. For remove, for searching, and for searching. And those are the 5. So I want you to sit down and think about what's the big O's of each of these. And you can either, again, put that in your code or in a separate text file. And this should be due a week from today. Good. Any questions?